So question 2 is how to solve y double prime plus 4y equals to 8 sine 2x. So don't forget, whenever you are solving any non-homogeneous ODE, the first part you are going to solve is your homogeneous part. So this is equal to 0. So the characteristic equation of this is r squared plus 4 equals to 0. There's no y prime, so we don't need another r here. So solving this, we are going to have r squared equals to minus 4, which means r equals to plus or minus square root of minus 4, which is 2i, right? That's plus or minus 2i, which means our y equals to e raised to power plus or minus 2i x. And this can be written in form of a cos 2x plus b sine 2x, where a and b are arbitrary constants, which means our y1 equals to c1 cos 2x and our y2 equals to c2 sine 2x. So I can write my yc, okay, let me write it. My complementary solution equals to c1 cos 2x plus c2 sine 2x. So since I have my complementary solutions now, I can now use the method of variation of parameters to find my y particular. So I'm going to assume that my y particular equals to k1. Instead of writing c1, I write k1 cos 2x plus, instead of writing c2, I write k2 sine 2x. So I'm going to enforce this condition, k1 prime cos 2x plus k2 prime sine 2x equals to 0. After enforcing this, I differentiate my yp twice. Yp, the first derivative will now give me k1 prime cos 2x plus, differentiating this one, k2 prime sine 2x. I differentiated the what's it called first, the um case first. Now I'm going to differentiate this one. I'm differentiating using product rule. So if I differentiate this second part, I'm going to get minus 2k1 sine 2x. Don't forget, since k1 is a function of x, I use product rule. You differentiate it the first time, k1 will be the one differentiated. We leave this one. Now the second derivative, we differentiate this one, we leave k1. That's what I just did here. Differentiate cos 2x, you get minus 2 sine 2x minus 2 sine 2x, we leave k1. Now let's differentiate the second one. We are going to get plus 2k2 cos 2x. Right? So we have differentiated this. Now, using these conditions, it means we can collapse this and say this is equal to 0. So we can collapse our yp prime equals to, rewriting this one. I would like to make this come first. 2k2 cos 2x minus 2k1 sine 2x. Right? Yes. So on getting to this place, we can now differentiate again. Yp double prime equals to, differentiating 2k this. Don't forget, k is a function of x, so we are going to differentiate it first. 2k prime cos 2x. I can differentiate this one without going further now. Differentiating cos 2x, I'm going to get minus 2 is going to come out, which means this becomes to 4k2. Cos becomes sine 2x. Differentiating this one gives us minus 2k1 prime, 2k1 prime sine 2x. If I differentiate this, sine 2x will not change the sign. Minus 2 will come out, 4k1 cos 2x. Okay, so I've differentiated my yp double prime. So the equation says y double prime plus 4y. So we are going to add 4 of this to this one plus 4k1 cos 2x plus 4k2 sine 2x. Everything should be equal to 8 sine 2x. So now let's compare. This is minus 4k2 sine 2x, this is plus 4, it cancels out. Plus 4k1, this one also cancels out. Which means I'm going to have something like 2k2 prime cos 2x minus 2k1 prime sine 2x equals to 8 sine 2x. There is 2 in everything, so I can divide everything through by 2. So I'm going to have k2 prime cos 2x minus k1 prime sine 2x equals to 4 sine 2x. Now I'll take this as my second equation. I take this as my second equation. I take this as my first equation. So solving these two equations um, simultaneously, I'm going to get something like, from here I get k1 prime cos 2x equals to minus k2 prime sine 2x. I take this to the other side. So I'm going to get k1 prime equals to minus k2 prime. If I divide this by this, I'm going to get sine 2x over cos 2x, which gives me, so we get k1 prime equals to minus k2 prime tan 2x. So this is what we are going to substitute into this equation. Let me see. Yes. So we have k2 prime cos 2x minus k1 prime. K1, we already have k1 here. So minus, since this is minus, it turns to plus, k2 prime tan 2x with the sine 2x that is already there, sine 2x equals to 4 sine 2x. Yes, so I can now claim this. Now looking at this, I can rewrite tan 2x as sine 2x over cos 2x, which means I can multiply everything through by cos 2x to drive this away, and I'll have something like k2 prime. If I multiply this by cos 2x, I get cos squared 2x plus k2 prime. Cos 2x is going to leave if I multiply through by cos 2x. So we have sine 2x, we have sine squared 2x equals to 4 sine 2x cos 2x, the cos 2x that I used to multiply through. Now, looking at this, I can factor out k2 prime. k2 prime into bracket cos squared 2x plus sine squared 2x. Now, using Pythagorean trigonometric identity, we know that cos squared theta plus sine squared theta equals to 1. Let our theta be equal to 2x. So this means cos squared theta here plus sine squared theta here equals to 1. So I can basically cancel out this one since it's equal to 1 and say my k2 prime equals to what? 4 sine 2x cos 2x. So we are left to integrate both sides. Now looking at this looks like an identity. Don't forget, 2 sine theta cos theta is the same thing as sine 2 theta. But here we are taking our theta as 2x. So I can basically say 2 times 2 sine 2x cos 2x, right? Equals to 2 sine theta. So basically this means this is the same thing as 2 sine 2 into bracket 2x, right? 2 sine 2 into bracket 2x, which means this is equal to 2 sine 4x. So it means k2 prime equals to what? 2 sine 4x. So I'm integrating both sides to get my k1. If I integrate this one, I get k2, sorry. So I get k2 equals to 2 is coming out, 2 integral of sine 4x. Now if I integrate sine 4x dx, what I get is 2 dot. Now if you integrate sine 4x, we are going to get cos 4x over 4. But since this is cos, if we differentiate cos, there will be a minus. But it is not here, so we replace it with here. So we put it here, so we have something like this cancels this here, equals to minus 1 over 2 cos 4x. So we have integrated and we have gotten our k2. So for the second equation, k2 equals to minus 1 over 2 cos 4x. Now we need k1. Let me see. We differentiate this. 4 is coming out. Over 2 is 2. Minus turns it to plus sine 4x here. That's correct. This is correct. So we have gotten our k2. And this means our k1 equals to k1 prime equals to minus k2 prime. K2 prime is 2 sine 4x. K2 prime is 2 sine 4x. This is what we integrated to get minus 1 over 2 cos 4x. Let me differentiate this. 2 cancels out minus. Yes. 2 sine 4x and 2x. Yes. So this means I can now, yes. So this means I can now simplify this and say k1 prime equals to minus 2 sine 4x is the same thing as saying, to render it in terms of tan 2x, in terms of 2x, I can now say this is equal to minus 4 sine 2x cos 2x. You know, this is what we brought from the onset. This is what we turn into sine 2x. So sine 4x, sorry. Tan 2x is same thing as sine 2x over cos 2x. Sine 2x over cos 2x. So I can cancel out cos 2x on both sides and say I have k1 prime equals to minus 4 sine squared 2x. So this is what we are now going to integrate. We are going to integrate both sides to get our k1. So this means k1 equals to minus 4 integral of, now sine squared 2x, we cannot just integrate this straight away. We can render it in form of what identity can we can use, yes, we can use sine square theta equals to 1 minus cos 2 theta over everything over 2. We can use this identity. So our theta is now 2x, which means sine squared 2x, sine squared 2x, sine squared 2x equals to 1 minus cos 2. Our theta is 2x, 2x over 2. This means this is 1 minus cos 4x over 2. Yes. So integral of 1 minus cos 4x. Instead of writing over 2, I can bring my over 2 outside the x and say k1 equals to minus 2 integral of 1 minus cos 4x dx. So this means k1 equals to minus 2. Integral of 1 is dx is x minus, if I integrate this, I'm going to get sine 4x over 2. Sine 4x over 4, sorry. Over 4. If I differentiate sine 4x, I'm going to get minus cos 4x, and 4 will be cancelled out. So I have successfully integrated k1. So this means I can now say, simplifying this one, I can now say k1 equals to minus 2x plus 1 over 2, if 2 over 4 comes in, 1 over 2 sine 4x. Why my k2? Okay, let me write it there. Equals to minus 2x plus 1 over 2 sine 4x.
Part 2. It's correct.
So coming from the onset, we know our yp equals to k1 cos 2x plus k2 sine 2x. So I can say my yp is now equal to, what's k1? K1 is minus 2. I'm going to multiply it by cos 2x. Minus 2x cos 2x plus 1 over 2 cos 2x sine 4x. Sine 4x, yes. Plus k2, what's my k2? That's minus 1 over 2 cos 4x sine 2x. These two, this cos 2x, this sine cos 4x. So that means I have to simplify everything to be in terms of 2x. It means I have to simplify everything to be in terms of 2x. So we are going to have minus 2x cos 2x plus 1 over 2 cos 2x dot sine 4x is 2 sine 2x. Sine 4x is sine 2 into bracket 2x, which means I can write it as 2 sine 2x cos 2x. Yes. So these two can cancel these two. So it means I have cos square 2x here. Minus 1 over 2. Let me write sine 2x first. Now, cos 4 is the same thing as cos 2 into bracket 2x. Cos 2 into bracket 2x. Which means don't forget, cos 2 theta equals to cos square theta minus sine squared theta. Which means I can rewrite this as in terms of 2x. Okay. So cos 4x is the same thing as cos 2 into bracket 2x. So this cos 2 into bracket 2x, yes, I can write it as cos square 2x minus sine squared 2x. Let me write everything in terms of, let me see, cos 2x, cos 2x. Let me write it in terms of cos squared 2x. So this one, I can write it as cos squared 2x minus, this is 1 minus cos squared 2x. Which means this I can write it as cos squared 2x. This one will turn into plus. Let me open the bracket. This is 2 cos squared 2x minus 1. So I can write everything that is inside this bracket as 2 cos squared 2x minus 1. 2 cos squared 2x minus 1. So I'm going to get something like minus my yp. I'm still on my yp. 2x cos 2x plus, this is gone. So this is plus sine 2x cos squared 2x minus 1 over 2, opening this bracket, minus 1 over 2. Okay, 2 is going to cancel this one out. Minus, if I open this bracket, 2x on 1 over 2 times 2 will cancel out. Minus sine 2x cos squared 2x minus times minus plus 1 over 2 sine 2x. So everything in terms of sine 2x now. So our yp, let's simplify it totally. Minus 2x cos 2x plus, okay, this sine 2x, this sine 2x cos, so both of them will cancel out, plus 1 over 2 sine 2x. So this is the simplified yp, our y particular. So we are now going to find our final answer, y equals to yc plus yp. And y equals to, our yc has been given as c1 cos 2x plus c2 sine 2x plus our yp, that's minus 2x cos 2x plus 1 over 2 sine 2x, and that is the final answer. Okay, this sine 2x, this sine 2x, you can write it as c1 cos 2x plus, since this sine 2x, I can say c2 plus half is also an arbitrary constant, so I can say plus c2 sine 2x, or let me write it as c3 if you understand what I mean. C2 plus half is another arbitrary constant, plus c3 sine 2x minus 2x cos 2x, and this is the final answer to the second ODE. So this brings us to the end of this video. Make sure you like, share, and subscribe. Thank you.